start the recording, make sure everyone gets benefit of this. All right, so welcome, and let's see, this week is week 5. So we've got, I guess, the basic routing lab that already going to be talking about, but let's do Sunday. We're covering chapters 8 and 12 this week as well. And then next week will be the exam 2. So that'll cover chapters 3, 4, 8, and 12. So we already had a question on the routing. So let's go ahead and let me go ahead and pull that up. Let me get rid of this for right now. All right, so that'll be in week 5 in our assignments. All right, so let's download that. All right. All right, so we're to drag a router and 2 switches and 3 PCs. Connect PC 0, 1 to switch 0, PC 2 to switch 1, and then turn on routing. So this is not static lab. Oh, okay. I was going to say I didn't see that one. Which one is the static lab? Let me look here. It's in week 5. Oh, okay, but it's not in the assignments. It's the static routing video. Oh, there. From the video. Okay, gotcha. That's why. It's just an added. I gotcha. All right, so then here in this lab, we've got 3 routers, well, 4 routers, and basically it's one central location. Probably think of this as like corporate, and these are your remote zones. So you want to enable all the networks to be able to talk. And so then we've got, let me see, so do we have these configured? No. Okay. All right, so all right, so we'd have to enter in all the IPs, and so we'd set the serial interfaces on the routers. So these are the serial interfaces, the red lines, because that's going back out to corporate. So that's dealing with like lease lines, T1 lines, T3s, something like that. So they're using the serial interface. So that's that serial IP address, whereas the fast Ethernet IP address is the line going into the switch. And so then we have basically 2 networks for each of these 3 routers, right? So you have the network on this side, on the fast Ethernet side, and you have the network on the serial side. And then this central router, which is, like I said, most likely would be like your corporate headquarters. It has 3 networks coming into it. So in order for PC0 to talk to PC1 or PC2, router 0 needs to know where to go, and that's just a normal default route, so the next hop route, and that's fine. But you'd have to you'd have to create a static route, saying that if I don't know where it is, go here. You maybe don't have to because it knows about this network. But if you're going to PC1, you need the static route because 0 doesn't know where that network is. It knows what this network is. So to get to router 3, it has no problem getting to router 3 because it knows that network. But this network here that PC1 is on, it has no idea. So it needs a static route. And so static routes, well, I guess you can actually do static routes from here. So basically, you would need to know the network, right? So let me pull up that. So PC1 is going to have the 172.16.00 network, right? Because it's the default of a class B. So in order to set up so that PC0 could talk to PC1, we would need the network of 172.16.0.0 with a default mask of 255.255.0.0. And then the next hop would be that router 3, right? So you need to get it to the next hop to that router 3. So I need router 3's address on this. So it would be this because I'm on router 0, which goes into serial 0. So the next hop would be 200, 200, 214. And then I would add that. And so this right here, this is one of the features of this, because normally you wouldn't add it on a Cisco router. You'd actually add it this way. It tells you the command that you would actually run at the command line interface, the CLI, and you can do that if you want. I think I do have a lab eventually that you can't do the config tab. You can only do the CLI. Try and look at the CLI and what it's doing, right? So this IP space route space, the network, the subnet mask, and then the next hop. That's the format for a static route. So you would do that on, you would do that on router 0. So that gets it to router 3. But then router 3, it needs, well, I guess if it's there, you probably should put in a route for router 3. So we would still need the so 172.16 network, right? 255.255.0.0. But this is going to go to router 2 on its serial interface. And so 233, 200, 200, 233. So now we've got that route. So now let's go ahead. We'll have to IP this up just to test it out. So router 3, since I'm already here, it's got address of 14 and 30, the 240 mask. So serial 0, 200, 200, 200, 14, 240. This is 200, 200, 200, 30, 240. So router 3 has its IPs. Let's go ahead and do router 2. Serial 0. Router 2 is 33. So 200, 200, 200, 33. And submask is 240. Let's turn it on. Let me go back to router 3. Well, let's just do gigabit 0 first. 10, 255, 255, 244, 254. So 10.255, 255, 254. Default mask. All right, let's go back to 3. I probably need to turn these on. All right. So then we need router 0. Router 0. Is 201. So 200, 200, 201. And it's 240. And gigabit Ethernet is 192, 168, 254. All right. 192, 168, 254. And turn that on. Turn that on. Okay. So now ping 200, 200, 233. Oh, wait. Exit. Ping 200, 200, 233. See, I just made a mistake too. All right. So I can't ping because I forgot the all important. I got to get back so I can get, I actually got the packets going here, but I can't get back because router 1 has no idea to get how to get to router 0. So we got to put our static map into here. And then I'm actually even doing the, because yeah, that should be fine. So network, what is 0's network? 192, 168, 0, 0, 255, 255, 255.0. Next hop is 200, 200, 200. What is router 3 on this side? Router 3 is 30. Add. And then, well, actually, what I really should do and that's why it's, you know, this is being too finicky. This is going to work for the PCs, but I want it to work for the routers too. So I'm on router 1. So actually what I'm going to do is I'm going to remove this. I mean, that actually would be what you would need to do for the routers to work. But I mean, the PCs to work. But since these router 0 and router 1 only connect to router 3, I'm just going to say any unknown go to router 3. So that's saying any unknown IP network I want to send to router 3. And so I want to do that on 0 as well. But you could have done what I did if you just wanted the PCs, but it's better in this case because of where they are. And then this is router 3014, 200, 200, 214. All right, so now if I go to the CLI, exit, ping 200, 200, 233. Why am I failing? Oh, because yeah. So once again, I've still only set this up for the routers or the PCs. So if I got the route, default routes, static route, yeah, I don't have one back. All right, so this should work. This should work. You shouldn't have to have one for the router, but 200, 200, 200, 0, 255, 255, 240. I shouldn't have to put that in, but 200, 214, 1. And so then let's see here. So we got 30, 240. So hold on here. So 128, 192, 224, 240 is 4. So that leaves 4. So it's at 16. So 16. So 16 goes to 33. All right. So what I'm doing here is saying to get to the first network, the router 0, it's on network 0, so /28. I need to go to router 0, which is 200, 200, 201. If I want to go to the next network, because we're a /28, we're going up by 16 each time. So if I want the 200, 200, 200 dot 16, I need to go to router 2, which is at 33. So now ping 200. Oops, we're in the config. Can't ping from config. Ping 200, 200, 200.1. All right, so we can ping 1 from router 3, but that's going to fail. Oh, wait a minute. All right. So router 1, interface 0, 200. Why is that not working? Oh, shoot. I don't know what it was in, but config serial 1 is 30. $233. Why? All right, so serial interface 1 is 30, and it's on. Serial Ethernet 1 is plugged into 0. 0 has an IP address. All right, packet tracer is really giving me a problem here. This is all right. Got an IP address on serial 0. It's on. We've got the subnet mask correct. 0, 200, 200, 230. Serial Ethernet is on. 200, 200, 230. Wow. I just don't even think we need these. All right. Well, why is it gotta? All right. Let's do router 2. It's just being flaky here, and that is really crazy. We've got IPs on it. All right, so router 3. Let's see here. 46. 200, 200, 200, 46. That's right. It's on. It's fine. need a route for router 2. Oh, wait a minute. That's one of the things, yeah. 46 is serial 2, yeah. Oh, thank you. All right, so 200, 200, 200, 46. But I did do a problem. We were on router 1 instead of router 2. But still, oh, that. I got it. I got it. That's why. I put router 2s on router 1. All right. This is why. Router 1. Yeah, see, these won't work on the same network. The numbers were close, but I forgot about the network is going up by 16. This 33 can't talk to the 30 because it's on the next network. It's on the third network, which is router 2. This is router 1. So router 1, its IP is 17. That's why. Okay, now if I go in here, yeah, and I ping 200, 200, 200. Router 3 is 30, right? So router 1 IP is not the FAQ. Okay, so now we're pinging. Let me get that again here. So router 1 is not the FAO. It is an FA, right? So router 1, we do configure. Oops, you gotta get on the other monitor. So the fast Ethernet or the gigabit Ethernet, right? We do configure that. But serial 0 on router 1 goes into serial 1 on router 3. Right. So what I did was I put router 2's IP address onto router 1. So the IP address for this network over here, I put it on router 1. So then it couldn't connect. It couldn't establish a connection because they were on 2 different networks. They have to be on the same network in order to communicate, or there's got to be a router in between them. So I put the wrong network on it. So now that I've got all the right IP addresses on there, I should be able to ping router 0, and I can. Okay, so I don't need routes because router 1 knows how to, everything goes out of router 1. I did set routes. I told it if it doesn't know the route, send it to router 3. Router 3 knows where router 0 is, but it doesn't know where PC1 is, which is a different network. So that's why I do need the routes. And so now we've got the routes set, except for I got the wrong route set because I think I did. Okay, so that's fine. but I got the wrong routes, I think, on here on router 3 because, yeah, so I want PC1. Okay, it's 17. Okay, so I got the right route for that. And did I get the right IP? Okay, I didn't do an IP. Oh, never mind. That's router 3. Router 1, the IP. Right, I got the wrong IP. Because, yeah, 1760. So PC1, router 1, 1716. 7216. All right, so router 1 should be 1716.255.254, which that's correct. I have a route going to 16 off of 33, so that is incorrect. I need it to be going to 17. Yeah, 17. So 172.16, 0.0, 255, 255, 0.0. That's 200, 200, 217, which, oops, which should be router 1, right, is 17. So I'm saying if it's on the 72.16 network, go to router 17. And so then I want the 92. So now I need to get back. So the PC0 is on the 192.168.0 network. So then I need 192.168.0.0, 255.0, and then this is router 1. Okay. So now that I've got the routes, this one's got a route right to router 3. Okay, so now if I go here on router 0, should be able to ping router 1's fast Ethernet address. So router 1 fast Ethernet is 255.254. So 72.168, 254. Why is that not? 16, thank you. And it does work. So router 0 can now ping this interface over here in this network, right? Because of our routes. So if I go, if I go here and remove this route, so I'm going to remove the route from router 3 to router 0. And then I'm just going to go back to router 0 and I'm going to redo the ping. It's still working. So usually I'd add, Oh, because I'm doing route from router 0. Hold on. Yeah, that's why that's working, because it can get back. But let's configure a PC, and let's do it from the PC and see see that it should fail. So our gateway is going to be um, router 0 is 254. 192.168.0.254, because it needs to know its router. How do I, my default route, and then its IP address is 01. 192.168.0.1 and default. All right, so ping 200.200.1. Okay, so we can ping the other side of router 0. So let's ping router 172, right? 172.16.255.254. All right, so it's failing. All right, let me make sure I've got the right one, right? So 172.16.255.254, right? It's failing on the PC. Oops, wrong one. It succeeds on the router, right? And that's because the route is missing on router 3, because router 3 has no idea how to get to PC 0, even though PC 0. So what's happening, if you actually had a network sniffer, the ping request is going out to router 0, and router 0 is going to send it to router 3. Router 3 is going to send it to router 1, and router 1 is going to say, oh, that's my internal network card, and send a reply. So the reply goes back to router 3, and router 3 says, I have no idea how to get to PC 0. I'm just going to drop it. And so we need to add a route back so that 192.168.0.0 255.255.255.0, and the next hop is 200.200.200.1. So now we're saying if we get anything from PC 0, its network, and its network send it to router 0. So now if I go back here to PC 0 and I do my ping request, I can get a reply, because now the ping can actually get back to the PC. Yeah, sorry, I made several mistakes on there, but is there anything else about the static routes? I mean, but mainly you have to have the routes so that the routers know about these networks. Now there are routing protocols, but they're way more advanced than what we want to do for this class. So we're just doing the static routes. Because there are dynamics and they can learn and do all that, but they do need routes though, and mainly it's pretty confusing. These are steps we could largely follow to set up. Mainly for these 3 remote routers, you just need the default route, which is the 0000 to 0000 mask, and then the interface on router 3. Then router 3, it needs a route for each network to its router, right? So whichever router it controls. So the 192.168 network is over here, right? So it needs a route from um, going to 192.168 to router 0, and then the 172 network, and then the 10 network. But it's really the main routes that you need to worry about getting right are on router 3, whereas the routes on 0, 1, and 2 are all the same. They just route everything to router 3. But so router 3, it has the specific route going to whichever router controls that network. And it's just basically a route is, how do I get to what network, right? So the 192.168 network, it's controlled by router 0. Router 0's interface that's connected to me is the 200.200.200.1 interface. So I just need to tell it, how do I get to that network? Who's the next hop? Who controls it, right? Um, and you could do that even if there were, even if you had to say another router here, right? You would still set the same route on 3 because it'd have to go to 0 and then go to this router and then get to the network, right? You're just telling it who's the next hop, where should I go if I'm at router 3, where should I go next to get to the network? And it depends on which network you're going to, and you just need to know the network ID, right? Because PC0 is on the 192.168.0.0 network, right? Um, the PC1 is on the 172.16.0.0 network. So, um, is anyone having trouble? I mean, is it with the networks and the subnetting? Is anyone having issues there? Um, we got the subnetting assignment that's still out due in week 8, but it's pretty large, and but as long as you know what networks you have, setting the routes, it's just telling router 3 which router to go for which network, and then routers 0, 1, and 2, they just send everything to router 3. You could set individual routes, but in this case, it's not needed. I mean, uh, just because there's only one way it can go. All right. Well, I wish does that help? Um, if not, maybe we can get together and I can go over it a little more. Yeah, thank you. I'll watch the video again. Okay. Okay. Yeah, please just let me know if you're still struggling with it. I'll see what we can do. Maybe we can jump on Google Hangouts and definitely I want you to get the concept. Yeah. Okay. Yeah, no problem. Yeah. Cool. All right. Go back and watch this again. Thanks for clarifying. Yeah, sure. Yeah, no problem. Um, but yeah, it's just they need to know, because router 3 has no idea about the PC0, PC1, or PC2 networks. And so without a static route, it can't get there. It doesn't know what to do. And just like when I took off the PC0 network, right? Um, PC0 couldn't ping, but the router could ping PC1 or the router. and that's because router 3 knows about router 0. So it was fine to get back. But without a route, it had no idea how to get to PC0, so it just dropped it. And that's all a static route is just how does the router know how to get there? If there's another router or hop in between it, there should be a route, telling it which router, because I have 3 choices. I don't know which one to make, right? So you're just telling it which of the 3 routers should router 3 choose in order to get to that network. But yeah, it's a good question. I mean, it is. Lab is due Sunday. Yeah, yeah. But I'm a little more lenient on labs though, so don't worry. If you're having issues, let me know, and we'll be fine with the lab. I want you to get them. I'd rather you understand it and it be late than you just rush and try to put something in. All right. You're welcome. Yeah, because I'm more about everybody understanding and grasping the material. Don't don't worry about it. Especially when we move fast here in the summer too. It's just a pathway I couldn't understand. Try again. Okay, no problem. Yeah, and the good thing is when you get it set up, they'll be able to ping. So and but yeah, because we're a summer class, I'm definitely a little more lenient because we do move very fast. So I'll accept late assignments on a lot of these, just so that you have enough time to get it and grasp it. Because in a normal 16-week class, you would have a lot more time to get these concepts down, and some of them take a little time. All right. Any other questions or any areas that you want to look at? Okay. Let's see here. All right. All right. All right. Well, if there are no other questions, we can go over some quizzes. So we've got quiz 8 and quiz 12. All right. So how many subnets can a /48 site prefix support? A, no, it's gonna see, right? Oh no. How many subnets /48 site prefix? Yeah, this is the IPv6. So let me look here. I don't think that's right either because it's a 48, right? Because that'd be 16, so it should be C, right? So you got a 64 is the smallest, minus 48 is 16. So 2y to the 16 is 65,000. Yeah, I just had to think of, I don't deal with IPv6 often. So yeah, so 65,538 subnet can be supported. That number looked familiar, right? Yeah, it did to me, as you know. Um, but yeah, but I was like, wait a minute, where is it? It's like /64. So yeah, the smallest network that IPv6 issues out is a /64. And so then if you're borrowing bits, you know, down to this, so you borrow 16 bits. If you got 16 bits, you can create 65,536 subnets. All right. How large is 802.1q tag that is added to the Ethernet frame when you VLANs? It 4 bytes. What command will set the native VLAN on a Juniper switch port? Uh, to be honest, I use Cisco, so I'm not even sure on this one. I'm going to do the switch port set native VLAN, but it could be it could be C, but we'll find out. IPv6 addressing does not utilize classful addressing, therefore every IPv6 address is classless. Yeah, that is true. They are class. They IPv6 does not use class like IPv4. What does the, yeah, what does the VLAN trunk protocol VTP do? I don't know. It's establish trunk. It's a protocol used by the trunk port for establishing a trunk with another switch. Um, I believe that is correct. I mean, it does share that, you know, it's all these are very close because it, you know, has a database on a switch master. Um, yeah, we'll go with A. A /24 CIDR block is equivalent to 255, 255, 255, 0. True. Yes, that is true. All right, with VTP, where is the VLAN database stored? B or D? Actually, it's C. It's on the switch master or stack master. When using IPv6, what would a /64 network likely be assigned to? See, now actually it's A, because a /64 is the smallest network that we can assign. Yeah, so yeah, it's the opposite. Uh, on certain Cisco products, what command can be used to create and send helper messages that support several types of UDP traffic, including DHCP, TFTP, DNS, and TACACS Plus? see. IP create. It's close. It's B. IP helper address. All right, subtracting an interesting octet value from 256 yields what number? D, the magic number. That's correct. A subnet of 255.255.2480 can be represented by what CIDR notation? C, yes, exactly, right? Because 255.255 is 16, right? And then if it was a 255, it'd be 24. So A is out, and so then it's between B, C, and D, right? Because their numbers between 16 and 24. And so then you just have to figure out, okay, where is the 248? And if you do the one bit, it's 128, two is 192, three is 224, four is 240, and then 248 is 5 bits. So 16 plus 5 is 21. So that was great. Uh, what is the maximum number of host IP addresses that can exist in a Class B network? See, it's actually A. Because we have 16 bits for host in a Class B, right? You got 16 for the network and 16 for the host, and so it's 65,534. A network with 10 bits remaining for the host portion will have how many usable host addresses? And this is usable. I'm surprised they didn't try to trick you. All right, so we got 10 bits for the host portion, which that's 2 to the power of 10, which that's 1024. And we need one IP for the network ID and one IP for the broadcast. So, right, C is 10 or 1022, right? Yeah, it's that's a good one to know when you're trying to do the large ones. That when you're borrowing a lot of bits for like a Class A and Class B, that's a good one to start with, because say if you wanted to borrow 14 bits, right? Where 1024 is 10, so then 2048 is 11, 4096 is 11, 12, and then 13 is 8,192, and then you see we didn't just double from there, so you can start with 1024. So knowing that 10 bits is 1024 is a good one to start with. Right. It is. It is. You get better at it the more you deal with it, but because it is a lot. That's why I say subnetting. It takes a while for a lot of people to grasp onto it, because it's just different from what we do on a day-to-day basis. What IEEE standard specifies how VLAN information appears in frames and how switches interpret that information? No idea on that one. Okay, it's C. It's the 1Q. Not sure, but yeah, it's 802.1Q is for VLANs. All right, a native VLAN mismatch occurs when two access ports that are connected to each other are both tagging traffic with different VLAN IDs. True or false? Uh, It's actually false. It's when two trunk ports that are connected and they each have different taggings. Because an access port can only have one VLAN, whereas a trunk port could have multiple VLANs, but then they need to match or you'll have a mismatch occur. So if you've got a trunk port on switch one and a trunk port on switch two, and they connect to each other, if they don't have the same VLANs allowed, then you're going to have a mismatch. But it's, yeah, so it is a tricky question because they're saying access ports instead of trunk ports. Otherwise, it's true. Uh, if the EUI 64 standard is used, what part of the IPv6 address is affected? Let's see. It's actually the last four blocks because what it does is it takes the last four and it assigns the MAC address for the machine. So it's those last four blocks. Yeah. And that identifies the machine itself. Network segmentation decreases both performance and security on a network. False, right? It increases in security and performance. Only Class B and Class C networks can be subnetted. False, yeah, false, right? Because we got Class A. Class A as well can be subnetted. All that is needed to provide communication between two VLANs is a DHCP relay agent. It's false. We need a router. We need a router because they're two separate networks, right? We need a router for networks to talk to each other. And finally, we have, you have been tasked with creation and design of a network that must support a minimum of 5,000 hosts. Which network accomplished this goal? So we have a lot of slash networks here, right? So with this, the smaller the number, the larger the amount of hosts, right, that you have, because you have 32 bits available, right? So, right, a Class B would definitely work, but it would be too much. But so these are all, these could be well, we're not even dealing with A, B, or C, but they're all smaller than a Class B, but bigger than a Class C, right? Class C could not support it, right? Right. It's at least, it was originally an A or a B that's being divided. So we're dividing it. And so all I'm trying to say is if if 20 if 22 was correct, then 20 and 19 were correct, right? If 23, that's going to be too small, right? Because a slash 24 is a C, right? That's 256. So 23 is 512, right? And then a 22 is 1024. 21 would be 2048. 20 would be 4096, and then the 19 is 8192. So we're going to have to go with a slash C 19 because that's the only one big enough to do 5,000. All right. That was one I was iffy about, right? Okay, so yeah. So 65,000 was for slash 48, right? Um, how large is the 8021Q tag? 4 bytes, right? Set native VLAN, yeah, ID. Okay, so that for Juniper switch, I had no idea. So set native VLAN ID. IPv6 does not utilize classful addressing. And the VLAN trunk port protocol, it shares VLAN data information amongst switches. And that was the other one I liked. I mean, it's, you know, but it is still about trunking. Yeah, so, yeah. But it shares the VLAN database information among switches that participate. Yeah. And it keeps it on the stack master, right? So and slash 24 is the 255.255.255.0 subnet. And there's the VTP is stored on the stack master, right? On the switch known as the stack master. Using IPv6, what would a slash 64 likely be assigned to as a small organization? To set the helper addresses, IP helper dash address. And that's if you want to use support several types of UDP traffic, so DHCP, TFTP, and DNS. You have to set this so it can go through the router, right? So you need you give it a helper IP address so it can send those on so they can traverse the router. Our magic number is taking 256 and subtracting our interesting octet value from it. A subnet of 255.255.248 can be represented in CIDR notation as slash 21. What is the maximum number of host IP addresses that it can exist in a class B? 65,534. And network with 10 bits remaining for the host portion can have usable host of 1022. And the IEEE standard specification on VLANs is the 802.1Q. And then a native VLAN mismatch occurs when two trunk ports, not access ports, are connected to each other and have tagging different traffic. So this is false. The EUI 64 standard is used. What part of the IPv6 address is affected? It's the last 4 blocks. Okay. I must not have hit false. It's like, I know that one, but it must not have took my answer there. Yeah, exactly. It's like, yeah, but yeah, so it definitely, it increases performance and security. Like, yeah. Only Class B and Class C networks can be subnetted, and that is false. We got Class A's that can be subnetted. And then all that is needed for right communication between two VLANs is a router, not a DHCP relay. So this is false. And then we've got a slash 19 can do 5,000 hosts. All right, so that is chapter 8. And we got chapter 12 here. All right. What is the size of an ATM cell, including header? Oh, geez. 53 bytes. What statement regarding the use of a cable modem is not accurate? So all of these but one is accurate. A, right. Cable modem does work at multiple layers. Yeah. Like most modems are just at the physical, but the cable modem does operate at other layers. But it does have backwards compatibility, and broadband provides dedicated continuous access, and this 3.1 does allow for full duplexing and 10 gigs. You should get that far. Oh, good. In an ISDN connection, what amount of throughput did a single B channel provide? And that's 64 kilobits. The T carrier standard. T carrier standard, also called T-CXR standard, utilized what type of multiplexing over two wired pairs to create multiple channels? It's C. It's time division multiplexing. Yeah, that's a lot of multiplexing. I get that one. WANs connect nodes such as workstation servers, printers, and other devices in small geographic areas on a single network, and that is false, right? It's a wide area network for a reason, right? What is the data link connection identifier, DLCI, utilized for? Uh, eh, that was packaged. That's close, right? Because it's used by routers, which determine which circuit to forward a frame to in a frame relay network. So it's kind of the same, right? But it's dealing with frames instead of packets. But I get it. Yeah. Yeah, exactly. Right. Because data link exactly deals with frames. You got it. Uh, which type of DSL technology has equal download and upload speeds, maxing out around 2 megabits per second? Uh, Close. It's SDSL. I think it's symmetric DSL. On an ATM network, how is the path that data will take determined? Frame relay route tray will establish each hop. No, it's D. Switches determine the optimal path between the sender and receiver, and then they establish the path before transmission. In a public switch telephone network, lines are terminated at the central office. They were a lot of there's a lot of words in there in those answers. There was a lot to digest, so don't worry. In a public switch telephone network, lines are terminated at the central office. Things quickly. Yeah, it is true. Yes. What is the maximum throughput of a DS3 connection? Basically known as a T3. Okay, it's 44.736 megabits per second. CDMA is an open standard that is accepted and used worldwide. It's false. It's closed. Yeah, I know, right? In a frame relay WAN, the ISP typically has the data circuit terminating equipment. Data circuit. Circuit. Yeah, I'm going to say DCE, DTE. DTE is at the customer. So yeah, I'm going to go with that. This is like way long ago. Considering that multiple users occupy the same channel, I remember the part a little from yesterday. Ah, good. I had to think for a second. It's like, because you got DCE and DTE, and it was like, which one is which one? Okay. Considering the multiple users occupy the same channel when using CDMA, how are various calls using the technology kept separate? B. Encrypted and such that the only appropriate device can decrypt. No, that's a good guess. I mean, yeah, because they're all pretty much saying the same thing. The packets are coded such that the individual calls can be distinguished, which really that's what all these are saying. But how they do it, they don't tell you. But it's C. Um, yeah, right. Where are MPLS labels placed within a frame? This means nothing to me, right? Okay, it's between the layer 2 header and the layer 3 header. Yeah, and it's MPLS is just another, like your T1s and your frame relays, and it's just a different kind of communication, and it needs some information to be placed within the frame. Um, and so it puts it in between the headers. Yeah, but yeah, I can't explain it much more than that. Yeah. All right, the DTE or endpoint device for a leased line is known as which device below? It's actually A, the CSU DSU. And this one I do know because yeah, and that is a DTE device because that's at the customer end. Yeah. Most satellites circle the Earth 22,300 miles above the equator in a geosynchronous orbit. And no ideas when getting into satellites. Um, to be honest, I don't know this one either. I'm going to say true. It sounds true. But yeah, yeah, it does sound like a pretty good distance. Yeah, exactly. But yeah, I honestly don't know about satellites. That's not what I dealt with. In metro settings, end-to-end carrier-grade Ethernet networks can be established via what protocol? I like space, but I don't know a thing about it. Okay. uh, see. That's a good one. It's actually the carrier Ethernet, for the carrier grade. So if you see that one again, remember carrier. Um, yeah, so it's yeah. I mean the metro carrier. I mean yeah, I get it too, but yeah, the carrier Ethernet, right? It answers almost in the question. So when using the DOCSIS 3.0, what is the maximum or minimum, minimum number of channels that can be used? A. Yes, A is correct. Uh, although MPLS can operate over Ethernet frames, it is more often used with other layer 2 protocols like those designed for WANs. It is true. Good job. Yay. DSL services require many subscribers to share the same local line, causing potential security concerns. It is false. That's cable. Cable modems do share. DSL, they have their own line. So let's see where we're at here. And we got them all. You want me to run through them one more time, or? Okay, sure. What is the size of the ATM cell, including the header, is 53 bytes. Which statement regarding the use of cable modem is not accurate? And right, the cable modems only operate at the physical layer of the OSI model is not correct. And in an ISDN connection, what amount of throughput did a single B channel provide? And that's 64 kilobits. Each B channel provides 64 kilobits. Usually you had two B channels and a D channel, and so you'd have 128 kilobyte connection, because the D channel, it's for management. It's not for data. And that was for your ISDNs. Yeah. A T-carrier standard, also called TCXR standards, utilize what type of multiplexing over two wire pairs to create multiple channels, and that's division multiplexing, TDM, right? So for T-carriers, the type of multiplexing is time division. And WANs connect nodes such as workstation servers, servers, printers, and other devices in small geographical areas. Is false. It's a wide area. What is a data link connection identifier utilized for? And it's used by routers to determine which circuit to forward a frame to on a frame relay network, right? Because it's data link layer. Which type of DSL technology has equal downloads and upload speeds for the max around 2 megabits, and that's the SDSL connection. And then on an ATM network, how is the path that the data will take be determined? And switches determine the optimal path between receiver and then establish the path before transmission. In a public switch telephone network, lines are terminated at the central office, which is true. I just realized our satellite question was correct. What is the maximum throughput of a DS3 connection? And it's 44.736 megabits per second. CDMA is not an open standard, right? So it's false. It is not open. A frame relay. In a frame relay WAN, the ISP typically has the data circuit terminating equipment, or DCE, which that is true. Considering that multiple users occupy the same channel when using CDMA, how are various calls using the technology kept separate, and the packets are coded such that individual calls can be distinguished. Where are MPLS labels placed within a frame? And that's between the layer 2 header and the layer 3 header, right? So we're dealing with frames, so layer 2 makes sense to put it there. The DTE, or endpoint device for a leased line, is known as which device below? And that's the CSU, DSU. And our satellite circle of Earth at 22,300 miles above the equator in a geosynchronous orbit. And that is true. So we learned something new. We know everything we need to know about space. If only it were that simple, right? In metro settings, end-to-end carrier-grade Ethernet networks can be established via what protocol? And that's carrier Ethernet transport. That's peak space knowledge. I don't know. I was just reading the other day about a dwarf star that went and disappeared on them. They don't know if it exploded or if it became a black hole. I thought that was pretty cool. They just know it disappeared. Yeah, we'll find out sometime soon. I mean, they'll be able to figure out one or the other. But yeah, I don't know how you misplace a star though, right? When using the DOCSIS 3.0, what is the minimum number of channels? And that's 4. Places space where they're finding that the laws of physics don't apply. Yeah, it's crazy what we're learning. Yeah, it's just amazing. Space is freaky. I will give you that. Yeah. As long as it just leaves our space alone, we don't need a black hole coming over and encroaching in our galaxy. Then we're good. Exactly. It would be bad. Although MPLS can operate over Ethernet frames, it is more often used with other layer 2 protocols like those designed for WANs, and that is true. And DSL service does not require many subscribers to share the same local line, so this is false. And that is our chapter 12. So there you have it. You just take these several times though, right? Because there's a few other questions we didn't go through. But so please make sure you take chapters 8 and 12 a couple times so you can see all the questions. And that way you'll be prepared for the test next week. Yeah, and you take it 5 to 10 times. Yeah, that's perfect. Yeah, exactly. You do it till you know it. You know it by heart, and then you can take the test because that's the best way. I mean, it's if you're not getting an A on my exams, you're not studying the easy way. Yeah, there you go. Exactly. Yeah. I mean, there's a lot of questions. I will admit, on an exam, there's a lot. So I'm not going to say you should be perfect, but you should be getting a B or at least very easily. Yeah. Uh, but there's no reason you shouldn't be getting an A. And just take them, like you say, 5 or 10 times, right? Some you have to do a little more than others, right? Some of these get really dense, and I can definitely know on like chapters 3 and 4, there was some stuff in there, and even on these chapters too, there's some information that's really really hard. Yeah. Take them through the week and then blast through them right before the exam. Yeah, exactly. Yeah. Yeah, exactly. Take them as the week goes, and then right before the exam, take them again, so you're fresh on them. That's a good plan. Very good plan. All right. Well, this is awesome. So, any other things you want to cover, or yeah, you're welcome. Good. Yeah, I think this is good. I think this is good. I'm gonna go ahead and stop recording here. So, if I get to the right monitor.